In today's video, we will be discussing Archimedes' principle. Archimedes' principle is a physical law of buoyancy which was discovered by a Greek mathematician and physicist named Archimedes. His eureka moment became a major breakthrough in the world of physical science. Archimedes' principle explains how an object behaves when it's immersed in water. It has given answers to how ships float, how submarines dive in deep waters, and why we feel weightlessness when we swim. So, let's find out the answers. Archimedes' principle states that when a body is immersed fully or partially in a fluid, it experiences an upward force that is equal to the weight of the fluid displaced by it. To understand it a little better, I am going to take the liberty of making a small change. For now, I am going to remove the word partially from the sentence. Also, as we know, fluid can be any liquid or gas, so I am going to use the term water instead of fluid. Now let's read the statement again. When a body is immersed fully in water, it experiences an upward force that is equal to the weight of the water displaced by it. But I am not done yet. Now I am going to split these two sentences. Number 1, when a body is immersed fully in water, it experiences an upward force. And number 2, the upward force is equal to the weight of the water displaced by it. We will look at both of these statements separately. Let's look into statement 1. When a body is immersed fully in water, it experiences an upward force. To prove the statement, let's do an activity. Okay, now I'll do a simple activity. This is a beaker which is half filled with water and this is a ball. I'm going to drop this ball in the water. Let's see what happens. Right now it's floating. If I try to immerse it, I can feel some resistance. And this resistance is the upthrust or the upward force that the water is exerting on the ball, and it's not allowing it to stay down unless I remove my hand. Question is, why does this happen? It happens because water also exerts a force on the immersed body against the gravity, that is from underneath, which doesn't allow the body to stay down. This force that the water exerts on the body is known as the buoyant force. So buoyant force is an upward force that opposes or resists the downward force of the gravity. So we have proved the first statement. So what is buoyancy? Buoyancy is the ability of an object to float in water. Any force that pushes an object in water is equal to the mass of the water that is being pushed out of the way. This explains why we feel lighter in the water. That is due to the buoyant force. As a note, always remember, the magnitude of the buoyant force determines whether an object will sink or float in a fluid. An object will sink only if the gravitational force acting on it is greater than the buoyant force. On the other hand, an object will float only if the gravitational force acting on it is less than the buoyant force. Now the question is, what is apparent weight? And what will be the apparent weight of an object that's immersed in a fluid? Apparent weight is the appeared weight, not the real weight. Real weight is the weight in air. Let me explain this to you. Suppose we have an object that is denser than the fluid. In our case, the fluid is water. If we want to know the weight of the object, we can simply attach that object to a string and weigh it using a spring balance. The tension of the string, which is due to the pull of the object, will be equal to the weight of the object, right? As we know that weight W is equal to mg, that is mass times gravitational acceleration. So tension T, which is the same thing as weight, will also be mg. Now, if we immerse or submerge the same object along with the string in the water, the tension of the object will be less than before. How much less will be the tension in the string? It will be less by the amount of the buoyant force. What that means is the object, which obviously has weight, when immersed in water is pulled down, but at the same time the buoyant force pushes it up. So the tension is basically the difference between the two, that is weight of the object minus buoyant force. And if we plug in the value of weight, it will be T is equal to mg minus bf. That will be equal to the apparent weight of the object. So we can say that apparent weight is equal to weight of object in air minus weight of the object in water or fluid. Let's do another activity. This is my object, a bucket, and it's quite heavy. I am going to weigh it. And as you can see, I am using a spring balance. The measurement on this balance is written in kilogram. And it can weigh all the way from 1 kilogram to 50 kilograms. So let's see how much our object weighs. If you look at it closely, it weighs around 4 kilograms. Let's zoom it. So this 4 kilogram is the weight of the bucket in air. That is the real weight of this bucket. Now let's see what happens to the weight if I put it in the water. And now I'm immersing it. It's completely immersed. Let's weigh it again. I'm using the same spring balance. And the weight is around 3 kilograms. So our object has definitely lost some weight in water. Apparent weight is the weight of object in air minus weight of the object in water. So, in our case, the apparent weight will be 4 minus 3 is equal to 1. The weight of the object in air, or its real weight, as you saw, was 4 kilogram, and its weight in the immersed water was 3 kilogram. So the difference was of 1 kilogram, which was the apparent weight of this object, that is, of this bucket.